Hey everybody, in this video we are going to solve the trig equation you see in front of you right now. And the directions are a little bit cropped off, but this is the broken one. They said to solve on the interval between 0 to 2 pi. And the 2 pi has a parentheses, so 2 pi is not included, but 0 is. So you would exclude 2 pi in the event that that would be an answer. And there is a hint, it said to extract square roots. These are non-calculator questions, and typically you would not have a unit circle provided to you. You're expected to do this in your head. So I'm going to show you solving this algebraically two different ways. I think if I did this in class, maybe I only did it one way. Maybe I did it both. I guess it depends on which period and if I had time. So if I'm solving the way the hint says, it says to solve by extracting square roots. It is quadratic, and normally you want to get anything of second degree or bigger set equal to 0 to factor it. But in the case that it's a difference of two squares, even if it's not a perfect square like 3, you would solve either by factoring using conjugates, or you can solve by extracting square roots. So that would mean if I'm extracting square roots that I would add 3 to both sides, right? I want to get the sine theta alone. So I have 4 sine squared theta is 3. I would divide by 4 first because it's not always going to be a perfect square. So you would have sine squared theta equals 3/4. Then I would take the square root of both sides myself. When you are the person responsible for taking a square root of both sides, you are responsible for putting the plus minus in front. The square root of 3 I cannot do, it's root 3, but the square root of 4 is 2. So now I really have two different equations to look into. I have sine of theta equals positive rad 3 over 2, and I'm looking at sine of theta equals negative root 3 over 2. Root 3 over 2 is a lot, as opposed to a half being a little, and root 2 over 2 being medium amount. And sine is the y value. So what are we visualizing in our head? What are we asking ourselves? What is the question? Really, you're doing cosine inverse, the inverse of cosine, and that means you're asking yourself the sine of what angle equals root 3 over 2. The sine of what angle corresponds to up a lot, and then the sine of what angle corresponds to down a lot. So here I would get the answers pi over 3 because it's tall and skinny like a tree, and the answer 2 pi over 3. Those are both up a lot. That's where sine equals root 3 over 2. And then these two answers, I would get that theta equals 4 pi over 3, not 3 pi over 3, that's pi, don't be silly, and theta equals 5 pi over 3. So those would be the answers. And then since it's only asking for answers between 0 and 2 pi, I only want to list those answers. If you want to write them in set notation, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And there you have it. So those are your four answers between 0 and 2 pi. If for some reason we wanted all of the answers forever and ever and ever, not the best way, but one way is to take each answer and just stick plus 2 pi n at the end of it. If you want it all, we don't. We're done. Done, okay? So if people are watching this on mute, I don't know. Done. But in the event that we wanted all solutions, you would put plus 2 pi n. And again, there's better ways to do this. For now, I'm just saying this, so don't come for me in the comments like, you can be more efficient if you do this. Okay, I'll do that later. Plus 2 pi n, comma, and then here I'm going to write n. I'm going to write what n is, okay? Where n is an element of, so it's like a sideways U with a line. The set of integers, it's like a z with an extra line on the diagonal part, and I'm going to cross my z because I'm not a newbie at this, and otherwise it looks like a 2. Okay, so if you wanted all solutions, okay, if you wanted all, you would stick that at the end, although there is a more efficient way, but time is money. Let's keep it moving. The other way to solve this without extracting square roots is to solve by factoring. So keep in mind 4 sine squared theta minus 3 equals 0. Even though it's not perfect squares, you could still factor it as if it were the difference of two squares. The square root of the first term is 2 sine theta and 2 sine theta. And then what's the square root of 3? Well, guess what? It's square root of 3. So you could still factor it. One gets a plus and one gets a minus. Then you would solve each of them and you would end up still with the same things we got before, root 3 over 2 and negative root 3 over 2. What is the benefit of this way? The benefit of this way is you can't forget the plus minus because when you factor, it's built in. Whereas when you extract square roots, you need to remember to put that plus minus, and guess what? I'm not new here. A lot of people forget. So that is the end of that example. I'm not going to graph this one because I'm trying to be efficient. I'll save it for good ones. I did a graphing demonstration to show you about multiple solutions with multiple angles. So go watch the last example if that's what you're looking for. And hopefully that was helpful. If so, go ahead, thumbs up. If not, go ahead, thumbs down. And questions, comments, concerns, or requests can go into a comment below, and I will get to it as soon as possible. Bye for now.